Hello, good afternoon, everyone. Hope you had a great weekend. So this week, we will talk about Redux. Hey, everyone. And in the morning, Aline talked about what was the name of the architecture behind Redux? He talked about the architecture behind Redux. Yeah, exactly. Flux, thank you. And now I'm gonna continue from there. I'm moving into React, and yeah, talking about Redux and dive into and move into React, like how Redux is used into React. So today we thought that we talk about the concepts first, and then the rest of the week is gonna be about code. This concept is a bit, I would say, spread on a different. There's like different aspects. There's, as you have seen in the morning, there's actions, store, dispatches, and so on. And so if you understand the concept now, even in an abstract way, then once you start writing the code, you will find writing the code much easier, and also that would also make you remember all the time. Like when you say reducer, when you type reducer, when you type dispatch, if you understand the concept before typing the code, that makes make the process of coding smoother, because you're not only copying and pasting, you're not only writing syntax. Rather, you're applying the concept, applying the state management in the code. So even if you find today that you don't know how to do this with React, that's fine. But if you understand the concept, that's actually the purpose of today's lectures. So in the morning, you saw that, okay, in React, we have state management. But if the tree is complex, like this one that we have made before, then state management becomes very difficult, especially in the cases where, if you remember the rule that we level up the state to the nearest parent. But what if, like I made a quick example here. What if we want to have a component here that toggle the right panel here, and the nearest parent of the state is going to be on the app. So in that case, we need to pass the state through props, through main, then title head, and then through nav wrapper here, and then the right panel. Also, we need to pass the state through info section, into info description, then here, then to the toggle right panel. As you can see, this would make the code pretty complex and hard to track the changes that we are making. That's why they introduced this library that is called Redux, in order to make state management more organized, let's say. So what is Redux? Redux is basically a way to centralize the state by having global state in the app. So in the root here, we will just have a store where, instead of having different states here, and here, and everywhere, instead we would have just a store. That store all the states. Or actually, you can say it's now one state, but it's a tree. Has the shape of a tree. You can imagine it as a JSON file, a JSON object, sorry. So imagine the JSON object, different keys. Each key is concerned with, we will talk about this later, slice of the state. But for now, let's imagine we have one state that is stored in the store. And in that way, we can access the state from any component directly to the store without the need to pass the state into the props for each component along the tree. And the second thing about React, so we have a store, we have centralized state. And the second thing is that we have specific patterns to follow when we update the state. So previously, once the nav item, let's say we want to do, okay, let's keep with this example here. Once we want to toggle this, we can write any code here to manipulate the state. Now, in complex code again, and also when multiple people working in a project, like a big team, let's say, this would become like a difficult task or a cumbersome task, because each component is trying to access the state and update the state in a direct manner. Like here, you can just write a code, any code that would update the state directly. The thing is, this, as we will see, makes the code unpredictable. We will talk about how the code is going to be predictable later on. But you can imagine that adding Redux makes managing the state more organized. I imagine it as it's like a set of rules to update the state, and there's many benefits for that. But again, the thing is, this would be obvious when we have complex components tree, like the one here. But most of our projects, they're simple. But I think the project that you will work on would be a good example for a Redux application. But yeah, we didn't ask about Redux in the project. We will talk about this more in details, but just have the concept, like keep in mind these two concepts when you hear the word Redux. We have a centralized place to store our state in the React app, and also we have specific rules that we follow or that we add in order to update the state. We are not updating it randomly from any component. Rather, we will define specific rules to update the state. So when to use Redux, when to use this technology, when you have, again, large amount of state that is needed in many places. So you have, okay, we have state that is needed here and here. Let's say we have 1, 2, 3, 4, 5, and let's say we need this state here and we need it somewhere else. In this example, as you can see, also from your previous experience in React, in coding in React, you can maybe understand how complex this would go when you just pass the state through props only. So when you have large amounts of state, and also when the state is updated frequently over time, when the logic to update the state is complex, and also as a good practice when you have a medium or large size code base, and there's many people. So again, the more the complex, you can summarize those. The more the complex your code is, the more thorough your components tree is, the more Redux makes the process organized and easier. So the output, the functionality is going to be the same. Like you can use props and use state that we used earlier. So you remember they use state. Okay, like yeah, you remember when we used to define constant, state, and set state? So this is state management, basic state management provided by React. You can use the same code. You can use use state and props to upload to make the code works. That would work. But when things become complex, you need to write too many states like this. You need to pass states from place to place. Your children components at the end would have too many props passed from, let's say, if you have state here, you need to pass states all the way, props, sorry, state through props all the way until here. So at the end, you would write a component with a big list of properties. So again, instead, we could have state stored here, and we can access it directly from the item, from the toggle right panel, and so on. So this is the main concept of Redux. Okay. Now, in the morning, you've seen it in, it was animated. So this is the whole concept of Redux and how it works. So again, even if you cannot imagine how this is going to be translated into code, that's fine. But if you understand this concept, once we dive into code tomorrow and the day after tomorrow, you would find things easier. Yes. So as we will see, once we run the code, we will provide the store to the root component, to the app. So yeah, we provide the store to the root, and we can access it from anywhere. Okay, so we have the store here. And okay, let's start from the things that we know. We have the components in the UI, and we have events, and we have the store that we talked about. And as you can see, our state is inside. So let's start from those arrows, the main arrows. Now, components, they cannot manipulate the state anymore. If you remember, we used to manipulate the states here from the components, right? By, let's say if we have a button here, then we would pass I think it's better if I opened previous code. Okay, just give me a second. Okay, this is the Notes app that we worked on previously. So if you remember, we used to okay, let's look at our state here, Notes. It's in the app, in the root, and then we pass through props. Yeah, through props we pass into Notes, And we have these notes. Yeah. So okay, the update note, we're passing it from notes, which is also taken from the app. And in update notes, we have update count. And update count, as you can see here, set nodes. Yeah. So we manipulate the state directly from the components by providing a callback function, passing it to the components. The component can manipulate directly the state. Okay, in the case of Redux, we excuse me, we cannot do that anymore. In order to update the state now, we use something called dispatchers. So I'm going to say new terms today, and I'm also going to say to talk about them from different perspectives. In order you have the big image at the end. So we have events, events like clicking, on click, on change, and so on. But instead of passing this state, as we've seen, instead of passing this state when the update count, which is passed to the event, the on click, we pass something called dispatchers. So dispatchers are functions that is used to basically dispatch, send actions. Actions also another keyword. Actions, they are objects. They have the structure of the object, like the curly brackets. And basically, they define what needs to be changed in the state. Then the store, we will talk about that one more time. We will repeat that one more time. But once we dispatch the action, the store receives the action. And the one who receives the action is the reducer. And reducers, they are functions that manipulate the state. So you can imagine reducers are as like if the store, or let's say if the state is inside a, I don't know, a castle, let's say. So reducer is the god. Okay. So the reducer is the only one who allows the access to the state but for manipulation only. So if anyone wants to manipulate the state, is going to be only through the reducer. So you can imagine the reducer as a bot, as a robot, and its mission is to update the state, manipulate the state based on the dispatched action. So reducer is only accessed, is the only one that can access the state and manipulate the state. Now, as you can see, this is the cycle, the cycle of manipulating the state. So if I want to toggle right panel here, if I want to toggle this panel, then I'm gonna click the event here, which is a click button. And then I'm gonna dispatch an action to the state here that the state should, like, let's say, toggle panel off. And once it's off, then we have the second cycle, which is the rendering cycle. So once it's off, then we trigger, this is the action is triggered by changing the state. New rendering happens, then we commit the changes into the right panel, and the right panel would disappear. That's a good question. Actually, I don't know why they call it reducer, but reducers, they are pure functions, and Pure functions, they only take value and they only take input and provide output through certain rules. This is the mission, you can say. But yeah, I don't know why they call them reducers. Maybe we can look at that later. Okay, so the reducer update the state. And as you can see here, the old state, once the action is received to the store, the old state is taken into account through the reducer to update the state. Or more precisely, to create a new state based on the old state. Actually, this is what's happening. We will talk about that also soon. So if you remember, when in code, we used to say, okay, let x equal 100. So we define it as 100, then let's say we want to update that into something else. We just say 101, right? So the old value has disappeared, but in the case of Redux, we don't do that. We want to keep track of all the values of the state or previous values. So what is happening is we define x1 equal x, then x1 equal, okay, x1 equal x, let's say plus 1. This is what we do. We define a new x1, a new state based on the old one, and then we make the changes. This is happening through the reducer inside the store. So you would have all the previous copies of the state. So this is state 0, and then state 1 based on state 0, and the action is to increase by 1. Then we just take the old one and increase it. So here we have the track. As you can see, we can go back in track. And there's also many benefits to that, as we will see. So, but again, this is the main loop of manipulating the state. Components, they cannot manipulate the state anymore. They have to pass dispatchers into events to send certain actions, which are objects describing the changes, what's going to happen. And then the store receives that through reducers. Reducers update the state based on the old one. And once the state is updated, then the rendering trigger cycle is gonna be triggered. But however, the components, they can read state. So they cannot manipulate, but they can read. They can extract a state value, read only. So you can see, using hooks, use selector hook, as we will see as well. Okay, here's some principles of Redux. Single source of truth. This is, you would hear that a lot. The entire state is stored in an object tree within a single store. So the state is stored here within an object tree and is accessed by all the components. They call it single source of truth. And the state now is read-only from the perspective of components. And the only way to change the state is to dispatch an action, send an action. It's basically an object describing what is happening. And finally, reducers are pure functions. And through reducers, we can define how the state is going to change in response to the action. So what is the benefit of that? The first or the most important one is that the state becomes predictable. So what do they mean by predictable is that only certain functions, which are the dispatches, using certain objects, which is the actions, can manipulate the state internally through reducers. So in that way, if a bug happened, or if we want to debug our code, we can trace that easily because we made this cycle of dispatch to the reducer, and then dispatch action to the reducer. We made manipulation in an organized manner by having dispatch actions to the reducers and then updating and then reading the state by the components. So an action is an event, and it describes something happened in the application. Actions, again, they are objects. So they have this shape, and they have usually at least type, and they have also payload. And in the type, we pass the name of the action. In the payload, we pass a parameter. So let's say we can pass an ID, or we can pass a value. We can pass anything, basically. But you should imagine that this is an object that is passed to the reducer, and in the reducer, we take into account if there's a payload or not, and then we do the changes to the state as we want in the reducer. So the reducer listens to action dispatched by components, listens in the store. So you have to differentiate between listeners in the components, like on click and on change, and listeners inside the the reducer as a listener. So this is listening to the user, the on change, the on click, and so on. They are events listening to the user, waiting for the user to click, to change, and do something. Reducers, they're listening to actions. They're waiting for actions. It's basically the same because actions are sent based on the components, but technically they are different because components, they're listening to the user. Reducers, they're waiting for the dispatched action. Okay. And the store where the state of the current application lives. Again, it's at the root level of the app, and it's accessed from different components. So what we can do to the state here is we can update or we can read. Again, so here from different perspective, the only way to update the state is to call dispatcher and pass an action to the reducer. This is the only way we can do this, the cycle. And we can read, we use selectors. This is one of the methods. Actually, it's the best way to do so, is to use hooks, selectors, to extract the store value. So also two things to keep in mind. Actions are the only source of information for the store. So the state, its only source of information is the action. So if you want to pass any new value to the state, it's going to be through the actions, through the payload. And for the reducer, each reducer takes the previous state and an action. As you can see, it takes the previous state and the action to produce, to update the state, but basically it's producing a new state based on the old one. So the state is immutable. Do you have any questions before we talk about immutability? Do you feel that this is so abstract? We are far from code. Or right. Yeah, so again, tomorrow, or maybe in the second hour, we can talk a bit about code, but we can, I mean, tomorrow, once you have the concept, once you remember the concept, once you look at the code, and once you type dispatch, type reducer, type action, you would go back to this diagram. You just remember this diagram in order to know what's happening. The whole purpose of Redux is to make state management organized, and for me, it's impossible to keep in mind what's happening without Redux, like the state, how the state is passed for each component. I mean, what state I'm passing, then jumping to another component, what state I'm passing. To solve this, once you have this, once you keep this in mind, and once you type the code of Redux, you would remember that, okay, the state is at the top all the time. So when you say the word state, it's stored in a store in the root directory. You know that the components cannot manipulate the state anymore, but they can do that by using dispatch. And dispatch, you can remember that, okay, I use dispatch, I pass an action to dispatch, and it's received by a reducer, which is, use the older one to update the state. So in that scenario, I mean, in this context, when we use Redux, you can at least for me, I can keep track, let's say, or I can imagine all the time that how state is managed, how it's organized in my code, where I'm passing the state to, and so on. But okay, let's maybe talk about state management in React. So how do you think, or how do you felt about state management in React? Like when we, let's say, when we developed the Notes app, and when we had like too many states on the app.js, hopefully, yep. But here it's for me, it's really difficult to keep track of like each one of those and where I'm passing each one of those, because you have to define the state here, and then you have to go to components and pass those. But instead, as we will see, we will have reducers here, like a new folder called reducers. We define reducers there, and in the index we would have our store encapsulating the app, and we in the components we pass, instead of passing local functions, callback functions, we pass dispatches, and we define actions. We will talk about that I think tomorrow, we pass actions. We can define actions here, or we can define them in reducers. But yeah, from today, like if you understand actions, reducers, these keywords, these new keywords, like the word hook, for instance. So when you hear the word hook, you know that it is a built-in JavaScript function that has a certain purpose to hook into a component and do side action or certain action. Again, this is in Redux. There's these terms: reducers, actions, payload, and so on. So from today, if you just like remember these terms and know what each one refer to, especially in this diagram, that I would say would be very beneficial in terms of coding during the week. So again, we would have the store here, and we would have reducers. We define reducers and actions, and in components, we instead of setting state, instead of passing callback functions, and callback functions usually also set state because it's here. Instead, we pass dispatchers and dispatchers with actions, and they update the state in the store. So this is a high-level view to Redux in React. Okay, so each reducer takes the previous state and an action, combine them, and returns the next state. So the state is immutable. What do they mean by immutability here is that immutable means it does not change. So the current state is not directly updated, modified, but reduces create a new state. This is what's happening based on the current state and the actions. So reducers pure functions, they do not modify the input. So they are functions, they take the input and always produce new output. This is the immutability I told you about, which is when we define state and as a normal variable, and then we give it a value of 1, and then new state. This is the state, it's stored in the store, and the new state would be okay. If you want to do this hard-coded, you have to do it like this. You have to say, okay, let's state equal state, and then you have to say state to, let's say the action is to multiply by 10, for instance, state to multiply by 10. So this is immutability, that the state is not changed or mutated directly. We're not saying state equal state times 10. Instead, we are defining a new one and giving it the new value, and the name is actually in the store is the same. It's going to be the state, but in Redux this is something we don't do. This is what Redux do. This is what the library is built for. They do this for us, and the reason for that is this is the benefits of having this, having the immutability. First, its changes are explicit now. So it's more explicit, let's say, even if we do state times 10, it's still explicit. But when we do it this way, we have the old value and we have the new value. So it's more explicit that we multiplied by 10, because we are not only producing the new value, but we are also looking at the old value, which is 1. So it's more explicit, easier to implement debugging tools. Clear, understandable flow of data. This is all related to technical, technical specs or technical aspects of different tools, debugging and state management, flow of data and state management. It's also easier to maintain a history of the state. We can navigate, of course, when we have a state equal 1, state times 10, and so on. And as you know, when we update the state, usually it's a process that we don't, let's say, we don't make counter like this. We don't count previous updates or how many times that we manipulated the state. But this is something Redux do. And by having that, we can have these benefits. We can have a clear code, and we can add, we can integrate different tools as well. But for developers, in my opinion, this is the most important thing as well, which is when there is different parties or different people trying to update the same state at the same time. So there's something called race condition, and which is the idea that if two users or two people trying to access the same resource and want to update it at the same time, this is very annoying from my personal experience. This is actually available in databases. When we have a database and when we have certain resource and two people, let's say you have built a database of adding a new trip, for instance, or editing an existing trip. Okay, it could be adding or editing, but okay, let's say adding a new trip. So two people are adding a new trip at the same time to the database. That is going to make a race condition. Okay, I'm trying to figure out a clear example of race condition. Oh, okay. Let's say there is a calendar and there is slots to book a car or something, and there is time slots. And at the same time, and for the same car, and for the same time slot, two people clicked on the exact same point. The exact same slot. Yeah, appointment also would work. So let's say two people are trying to book the same appointment, which is on Monday at 11, for instance, and they logged into their accounts at the same time. Okay, they clicked on the book button for the same time slot at the same time. So which user is going to book the slot? That's called race condition. And databases solve it in different ways. So one of them should book the slot, the other one should have an error screen. But if we don't handle race condition, both would receive an error, or both would think that they booked the slot, but actually what was inserted in the database is one of them booked the slot, and it's by chance, basically, who is more faster in milliseconds, you can say. So we avoid these conditions by having loading screen and telling the other user, okay, loading something, and then the first user is booking. We book to the first user, the second user we give loading screen, and then after that we tell the second user, oh, sorry, something wrong happened, or the slot has been booked or something like that. So to avoid that in the state, like if there's two components clicked on the same time on the screen, let's say, and they're updating the same exact state, we can avoid this condition by having immutability, because each time we're not updating the same variable. Rather, we are creating a new variable based on the old one. So this is the first user is going to create a new variable based on the new one. And the second is also going to do the same. But the second user might take this state as the base state, or might take this one based on time, based on, it's again race condition, based on milliseconds. But we avoid the error, and yeah, we avoid unexpected behavior. And the reason again is that each user create a new state object. So this is a bit advanced, I would say. And Redux in general is used in complex code, but you can use it in simple projects as well, because it makes managing the whole state in the code much organized and much predictable. Okay, so this is snippets of code for the reducer and for the store and the dispatch. So to keep in mind the diagram and the code, how you can link both. So again, reducers, they are functions. They are pure functions. They take state and they take action. And usually they have this shape of switch, and they look at the action type. And based on that, which is the name of the action, we do something. We basically describe the behavior of that we want to apply to the state. So for instance, here we switch based on the action type. We have 3 actions: action plus 10, which we take the old state, add 10 to it; action minus 10, we subtract 10, and we have the 100, which basically we make the state equal 100. And we have the default, which means if the action is not one of those, then just return the old state. Or just here return means like this is the return. We basically return to the state the new value. So if the action is not defined in reducer, then just keep the state as it is. So that's why the code is predictable. You can define through the reducer, which is the bot at the door, which is the only one updating this, manipulating the state. The code is now predictable. It's only manipulated through those defined actions. And we have the store. Usually we just say create store, and we pass the reducer to the store. And then we pass the store as a property to the root. And inside components, we dispatch objects, we dispatch actions. So we just pass the type. And once we do that, as you can see, the switch would work. We will receive the type. And based on the name, so here, for instance, I'm passing action plus 10. So action plus 10 is going to be triggered. So I am passing action plus 10 from here as an action. I'm passing type. I'm passing, yeah, this object type action plus 10 here to the reducer, and the reducer take the state and the action plus 10. Okay. Here, state and action, which is action plus 10. So it's going to return state plus 10. So this is going to be state plus 10. And we use, okay, the component here, read the state value, and triggering happens. So or maybe from here. And as you know, after we trigger, here we trigger by a button or a card, and in the component kitchen or in React, in the back end of React, we render the new card or we render the new component and we commit that into the node. So, and this is based on changing the state. And after that, after the commit, we are going to update. We're going to update the component. So this is the cycle, the new cycle of React and Redux. And this is example of code. We create store, and then we dispatch actions, and we have reducers, pure functions that take input and just as you can see, return output. So this is Redux. This is how we apply Redux in React. So any questions? Any concerns? Again, if you like from today, if you just remember those, dispatch, like the new keywords, what do we mean by dispatch? What do we mean by action? What do we mean by store? What do we mean by reducer, and how the cycle works? Once you write the code and start typing reducers, start typing these keywords, you will find everything much easier. Okay. Okay, let's have a break for 5 minutes and see what we can talk about in the coming hour. Okay, sorry, I had connectivity issues. Okay, so let's talk a bit about code, since I guess everyone like got the main concept. So we can transition into code a little bit. So we have this Redux example, and in this example, they're using pure Redux. So as we will see during the week, there's different way to apply Redux into React. But this is let's say the pure way. We are using the Redux library, but in practice, they're using different tools. But again, we will see that in the future. So as we do always, we install the library npm install, and okay, as you can see, the whole state is stored in one JavaScript object in the store. And you will notice that this concept is can expand a lot, and there's like different there's different advancement or different additions that is added to Redux during the years. So if you go to into the official documentation, you'd find it a bit, or at least I found it a little bit like different than the normal documentation that you would see in a library. For instance, where I found the confusion, it was with yeah. So here you would have, as you can see, there's React Redux, and you would have Redux. So yeah, this is Redux, and there's React Redux, and inside Redux you would find essentials, and you would find fundamentals, because as Alim explained in the morning, it's based on a certain architecture, the Flux architecture, and then it become Redux, and then it transitioned into React, and there become an official documentation called React Redux. So at the end, we will use certain tools, but today I'm gonna talk pure Redux. And if you look at the code today, link it to the diagram, and then once we write the code during the week, everything is going to be smoother. Because the whole idea is to make state management organized and simpler to grasp and understand. So yeah, that's why also we need to go into Redux bit by bit. So here we have this is an action, and we just give it a name. They call it type, and usually it's in capital letters. So the action is, we describe what is going to happen. We describe in language, you can say, and the action is an object and can take a type and a payload. The payload is as you're passing a parameter into a function like this, and this is our reducer, which is this one. And the reducer is, so here they're using if statement, but it's usually a switch. Yeah, so the switch is the most common approach to write a reducer. And you can have a default value of the state here. If you remember in This is how we define the initial value in React state. So this is the built-in state of React. And here we define the initial value once we define the reducer. So, and also reducers are defined into their own files. So they are not in components, they are in different files. And they took the action, and also actions, about actions. Actions could be, we'll talk about, I think, that tomorrow. I'm saying we will talk about too much today. But yeah, so you can imagine a new file as a reducer, and that it takes, it manipulates the state, and it takes actions. And if you remember from the diagram, we dispatch from components, and we dispatch an action. So you have two options here. You can either define the action in the component, right, like here, or you can define actions inside the store, inside the reducer here. But from the component, you basically select what action you are going to choose here. So you can say there's two approaches. So either we have a file called counter reducer, and the actions are defined below, or we can have the actions inside the component, and we dispatch the actions from there. We will talk about that tomorrow in details. Okay, and we have the create store. So we import the store from Redux. Again, this is classical way, if we can say that, of using Redux. We import create store from the Redux library, and then we define the store here, where we pass a reducer. So reducers usually in different files, and stores usually in index.js, because we want to wrap the app.js. So yeah, usually we just define index here. Store here. Oh yes, sure. And then this is how we dispatch. We dispatch an action all the time. The action is this, it's an object. So as you can see, dispatch is this is called inside a component based on an event that is happening on the screen. Like here, we dispatch. And here in this example, the action is very basic. We have type and an increment. So we can define the action in the component, or we can define it in the reducer. If we define it in the reducer, then we need to export the function of the action. So we will define functions that would return an object, which is the actions. So we define action functions that return basically actions, and then we call them we import them from the component, and then we pass them here. So we say dispatch, dispatch, and then we say the function, and then we can pass a value if we want. But here in this example, we only having reducer here, and we are only having type increment here. And And as you can see, we have this store.get state here. This is a way to access. This is how we access. This is how we read. Again, this is a bit classic or old way to do this. Store.get state. And we do dispatch one more time, 1, 2, 3, and then we get the state. Basically, we increased by 3, and then we made 0, then we made decrement. So as you can see, we are updating the state all the time, and because of look how many operations we're doing, and you remember the immutability, which is we're not directly modifying the state, rather we are creating a new one. So for each time we are creating a new state, then we are increasing that. Then this one is based on the new one, we're increasing that. And this is all based on the new one, and we are producing a new one, a new state, and so on. And those all could be navigated. All these values could be navigated. We can go to the state at this time because of the immutability. Yes, Samina.
So when we create new states, what happens to the old state? How do we dispose of them? Or each time we are constantly creating new states and new states. So wouldn't that be a lot of storage that has been used? Like, how do we release that storage?
Actually, this is happening here in the store. This is how Redux works. Actually, this is a good question, but yeah, this is internal work of Redux that when it comes to size, I don't know how they are handling this. Like Redux mutable state size, but this is something we do not manipulate. It's not. It's not the job of the developer to do so. Actually, this is one of the values of Redux is to do this. But okay, this is not the answer to the question. Maybe let's look at so the idea behind immutability is that you have data that never changes. Never changed because we are creating a new like the store, inside the store, the user create a new state based on the old one all the time. So we have always fixed fresh data all the time. So again, that's simpler for debugging and for programming, especially when it comes to technicalities. It's actually not. Like a new state is created, so it's not overwritten. So yeah, I understood your question that what is happening to the size, but to be implemented. Okay, this is not answering our question. Redux immutable state. What does invariant means? Oh, okay, it's a library. Okay. Okay, let's see the community. Okay, immutable objects, new states by passing the current state to a pure function, new object. Instead, state changes are represented as difference between the input and the output. Yeah, it is a requirement as well. Exactly. So the purpose of all this is to have accounting. And yeah, this actually a good concept. We can look at the state as snapshots of the values over time. Um, they never mutate, returning newly built objects. So they return always new objects. And yeah, we saw the benefits of that. And their signature is always function name. Yeah, they take always state and action and they produce an output. So but the thing is, yeah, the question is the size. I understood your question. Let's see if to increment the count. So we make these reducers. Yeah, that's the reason, which is shallow also equality checking. We saw that. Um, so so reducers are pure functions, and pure functions produce new values. So we have to yeah, it's going like the state is going to be immutable, and also it's safer. And as we saw, there's many benefits to that. But I'm actually I'm not sure about this shallow equality checking. Yes, it's this is my understanding. This is my understanding is that uh, even though even though we usually we do not like I would say it's not usual to go back in the state to a previous state. Rather, you can just update the state with the new value that you want. So like the benefits, they are more of like from a technical point of view, as you can see, rather than a developer point of view. Yeah, like this is clear for me because it's happened to me. Um, but yeah, when it comes to organizing, when it comes to organizing how the state is updated, I think, yeah, this is the value to the developer. But when it comes to this part of mutability, I think this is more of a technical, more from the technical perspective, that instead of updating a certain state, we are creating a new one. But yeah, let's see, does Redux save all previous? Okay, okay, let's go to the documentation. I think that's better. And yeah, that's yeah, why I told you about the documentation. They have this and they have this. So what's the difference between fundamentals and essentials? But anyway, yeah, mutable here is changeable. So it's, if it's immutable, then it can never be changed. So JavaScript objects and arrays are mutable by default. So if you have the object, which is A1, B2, you can go and say object.b equal 3, and you update, you basically mutate the object directly. Here, the same. But for the values to be immutable, you have to make copies of existing code and then modify the copies. So here we have object of another object inside AC, and we have B, another key here. So if we want to update object, we first copy the object, we define new object, we call it 2, copy the old one, then spread that, then we overwrite by typing A and typing C. We overwrite the old values. So this is basically like saying object.a equal equal object dot yeah, object dot a dot c something equal 42. This is equal, yeah, this is equal to saying just c equal 42 basically. Yeah. So Redux expects that all state updates are done immutably. And yeah, let's see here, you have immutable as well. Okay, so this is the rules of immutability, and this is why I think they went with mutability, is with immutability, is to have less side effects and to make the code more predictable as possible. So it's always retain the same value when it's given the same inputs. So if you give the reducer an action with certain payload, whenever you do this same action and the same payload, you will have the same output. But yeah, it depends on the previous state. And no side effects means that it's only return a value. It doesn't call APIs, it doesn't call any other functions. It just return that value. Okay, yeah, console math, all those are examples of side effects. Um, okay. Okay, so when we define a new value, how it looks in memory, we just define crayon equals this object. And then when we update that, we just delete the old one and yeah, have a new value with blue. But no, this is the old way. Yeah, this is they're talking here about differential equality. They're not talking about immutability. Yeah, here is how Redux works. Okay. Okay. This is 5 years ago. Yeah, here's for me, I was like, we have essentials, we have fundamentals, and we have Redux and we have React Redux somewhere else. So it looks like that the Redux is like the progress of building Redux until today is just they kept everything, I think, or at least they kept many stuff while updating, or yeah, I don't know why they have those separately. And okay, okay, so for me, immutability, I think we like understood or we learned that okay, the state is immutable. It makes copies of the old value, but I cannot see if we keep track. Yeah, this is something I'm not sure about now. If we keep track of all the previous values, even though it's written somewhere that that's the case. Um, okay, immutability, you've been there. Okay, maybe that's yeah, I'm checking ChatGPT. I think we can access the previous states. Oh, okay. Previous states are not deleted, rather they are managed within the application state history. Right. But yeah, how can we access the old ones? Right. Yeah, I think, yeah, I'm just thinking that, yeah, this is something we can do. It relies on the application environment to handle storage. Okay. Redux persist. Okay. So the state, only the previous state is kept. Yeah, so we only have the previous state to create the new one, but during our updates, we can store the old one and send, yeah, we can, if we want, we can store this, or yeah, we can store this and update the state, the new one. And once the state is updated one more time, we can store the old one and take the updated state. Yes, exactly. So we can access to only to the previous state. So yeah, Redux by itself alone, it does not save a history of states, but it only have the last one, the last state. And once we trigger the new or dispatch a new event, dispatch a new action, then we can save the old one and update the state. So in that case, we can, as mentioned, as Samina mentioned, we can use Redux persist to save parts or the entire Redux state to persist and store it. But yeah, that's not needed, I would say. That's not necessarily, but depends on the case. We can do that. Yeah. Okay, so we were talking about immutability, right? Changes are explicit, easier to implement, debugging. It's yeah, flow of data is clear and the race condition. But again, this is benefits from technical perspective rather than from the developer point of view. What we care about more is like it's predictable. You can track who made the updates and how it's done because you define reducers. So you're updating the states through those, and you bypass the action from dispatches in components. So you have the cycle. The cycle is the only way to update the state. So it's more predictable and more structured. Yeah, the code is more organized. So this is the benefit from the developer point of view. But I think immutability, it's more technical, more deeper concept. Yeah. Okay, looking here at an example of an example of it's not working for some reason. Here we have a user, we have a store, and they're all on the same page, on the same file. So let's take a look at that. So, and there's here also without using, only using Redux. We're not using React either. So we define the store. This is the first thing to do. And we subscribe. This is also, I think, I'm not sure if it's even deprecated. This is old. We don't subscribe anymore. We usually subscribe, components subscribe to states, but after they introduce hooks in React, now components, they use hooks to get the state. So we subscribe to render, which is okay, the user takes state and the initial value, which is object of value 0, and it takes action. And here, as you can see, they made, if you have different states within the state tree, you can make something like this. You can define counter and then the action. So we are updating the counter state by passing increment. This is same as URL. So you do that by, like, it's up to you how to write this. This is an action that you write, you pass, and you do the action here. You describe the action. So we have the old one, the old state, and then we update the value to the state, the current state value +1. So basically we are making this one once the user pass, like dispatch this action. And here, as you can see, we are doing the opposite, decreasing. So again, this is, we're defining here the actions. We're defining what's happening to the state here. And the actions is received from dispatches. So let's look at dispatches. Here, dispatch, and we pass actions. And actions are objects that has type, and they have also payload, as we will see tomorrow. So we can pass type. Type is like a name, you can say. And the payload is any data that you want to pass to the state. So let's say you want to, instead of +1, you want the user to decide what number to be added. Like, we can allow the user to input something, and we can pass that with a payload and send it to the user with the payload. And so yeah, this is using, as you can see, Redux, no React, in JavaScript, inside an HTML file, everything in one file. And we are just basically document, get element by ID, event listener, function, timeout. Okay, without the timeout, we are decreasing and increasing, but it's not working. So this is another example of Redux. I was somewhere here. Okay, yeah, so this is the app that we were talking about. Also in one file. I think this one also without, it's not in React. We will get to know better ways to structure React Redux code later. Okay, so this is React, but only in one file, and we are using render app, which is rendering the root app. Yeah, do we still, yeah, React DOM here, and here just new render. Anyway, yeah. So let's look at this code as a whole in one place, because as you know, usually, if you remember when we started, we used to add everything in the app.js, all the HTML elements like here. Then we decided to make components, so we made a new folder called components. So we will do the same with reducers. You would have a place, you would define reducers and assign them into your store. So you define reducers, you have components, and you would also have a folder called reducers that you would assign to the store as well. Okay, so we define the store, create store, and the store takes the reducer. Now we can have also multiple reducers, but there's a different way to do that. As you can see here, we are passing only one, but usually we can use a function to combine reducers and then pass combined reducers into create store. In the reducer, again, remember it's a function that takes state and takes an action. And we can define here initial value and switch statement. And of course, it's pure function. Remember that it takes only input and return output. That's it. We don't call another functions. We don't call any APIs and any side effects. And for, yeah, this is also a way and a classic Redux way of getting the state here. But yeah, as I told you, we are using hooks. You can get the value of the state here, and here we increment and decrement. And we can render that after that. Actually, let's make this. Let's create this app, this function. Yeah, this app. Okay. Okay. Yep. Yeah. Any question? Okay. I just do. unknown command, or should be npx. Yeah, we will have many examples during the week, but um, but in my opinion, you just do not uh, forget this while you code. It will make things much easier for you. So that's why if you today, yeah, if we try to link the concepts into this and then the code into this, and then during the week we will learn the syntax of React, of Redux in React. But for now, just dispatch action. Action is object, dispatch function, components, reducers, pure functions, in stores, they receive um, the action with the old state, they produce a new one. And then we listen, components listen, triggering has happened, and we have updates on the screen. Okay, here's our example. Um, okay, and then npm install Redux, and then I think we should install it here. And in we can do everything in app.js. So we can create, we can import store. Okay, as you can see, this means it's deprecated. So this is not used anymore, but I think it's still functioning. We can still use it. And we have reducer. And then we define the store after that. From the create store, we pass the reducer. And inside our app, we are returning and then the root, okay, it's working for us, but store.subscribe in the app. The app is okay. So this is happening in index. So we should subscribe store here. So we should define the store here. And we need to import okay. Okay, we're dispatching type with store, but we don't have store here. Um, okay, that's something. Let's try subscribe the app. Would that work? Okay, we can actually do this. And yeah, we can have this and render app. Let's see if that will work, because this is again, this is not, they made things much easier when it comes to syntax. So even the render is old, like root or okay, root is not defined. Yep, we forgot this. Okay, actually it's not, it's the same. Create store is defined. Recruit. Okay, we should use the index because we are using create React app. So we should have the store here, and we need the store here as well. So what we can do is we can have the reducer and the store here. that would make this. Okay, we could replace this. Um, okay, so this is the how we should. Is it like this? This is the new way of passing the store. And is it provider? Actually, I forgot the syntax. But so yeah, our problem is with rendering. That's the issue. But at the end, yeah, okay, they're mentioning here that it's old. And we are using create React app, so we should have the index.js, and to pass this store to app, we need the provider. But yeah, I forgot the syntax. I think might be mentioned here. Or in the Redux documentation, right? Okay, anyway, we'll look about we'll talk code a lot this week. But yeah, this is a general idea of how Redux code looks like. So what you will notice that you will not like manipulate the state directly. This is the most noticeable difference, which is here. Usually we just pass its state directly to a callback function. You will notice we're just calling store dispatch, and we don't care about the word state here anymore. We just dispatch the action, as you can see. And in the reducer, we take care of the action. And again, reducer is going to be on a separate file. So you will notice that, yeah, we don't have access to the state anymore directly. Okay, any questions? Tomorrow, again, we will start coding gradually. Yeah, that's why actually we in the beginning we decided that this day only concept without any code, but slowly and like keeping the concept in mind is like really great in making your coding much easier and much how to say it, you know what to write when you have the concept in mind. So if you know how Redux works, you have the concept in mind, you have certain image about the concept. Once you type the code, instead of going in online, taking snippets from here and there, asking ChatGPT and putting the code here and there, it's gonna be functional at the end, yes. But if you have concept in mind and write code after that, then things will become much easier. But yeah, it takes time, I agree. So no need to rush. We have 1 week. We will look at the code tomorrow again, one more time. Also the day after that, also on Thursday, we will talk about the toolkit, which is the how Redux is written in React at the end. I mean, the recent way to write Redux in React, which is using the toolkit and using another concept, which is slices. Yeah, so we'll talk about that. But anyway, gradually, if you feel overwhelmed, then don't worry. We will talk about that this tomorrow. We will keep talking about the concept during the whole week. And if you want, I can send you the this diagram, and I'll upload as well. I'll upload the PDF, and I'll put the diagram at the end if you want. Okay, let's take a break, 5 minutes, and then we will start the lab. Yeah.
Yaman, can you open the breakout rooms?
Yeah, yes, sure. Give me a second.